I appreciate it. All right, hello everybody, and welcome to the March 12th meeting for TVM development discussions. We have today a few agenda items that we'd like to discuss, and they were submitted courtesy of Eric. Eric, would you like to introduce the items that you put on the agenda?
Yeah, so see, these are sort of a collection of different PRs that have been working to add some low-level functionality in Relax to allow for uh, some additional use cases that see I've been running into as well. So one of sort of the first one, and apologies as I have too many windows. Yes, this is the one where I started opening them up. And so effectively it's how can we have some additional explicit representations of things that are currently implicit, so that way as they are being lowered, the lowering can occur at the decision making and steps, and the VM specific steps can then sort of be separated, and there can be a way within the higher level relax to express some of these concepts. So as an example, let's see, the first one of as an example of something that has and shoot, there we go. So I'm going to share my screen just because that's probably the easiest way for it. Having operators that are specific to read, functionality, or to read parameters out of a DL tensor struct. And so this is something that is implicit as part of, the match buffer syntax, where if you have a r.tensor and you are match casting it to r.tensor d type equals int32, then that'll generate a reading of that value and an assertion that it's the appropriate type. However, that isn't necessarily sufficient for all cases, because the one that I was running into was, suppose we want to have a function where the user could provide either float 16 or b float 16, and they should be normalized to the same data type. There isn't a way to express that conditional conversion in terms of a match cast, because if you attempt to do a match cast, well, whichever type it isn't would fail. And so, this way, the operators to read runtime information are, or can then specifically be there to extract information from the runtime type, and then perform a conversion or not as required based on the runtime type. And then everything after that still proceeds with the normal relaxed data flow after we've normalized the inputs. Which then led to sort of the next one, which is still in progress, that a lot of these would become primitive data types, that if we are calling a function that would, we're calling an operator that returns back a, a integer value specifying what data type it is or what shape it is, then we have the language to express a value in terms of those, just with TIR expressions inside a r.prim value. But when those occur inside of a relaxed conditional, it would produce an error can't remember exactly when the error occurs, but it's I think during the codegen step, as it's expecting a scalar constant and a primitive constant is not allowed in that context. And so this is expanding the functionality to allow for those host side computations based on a prim value. And so that way you can, between those two, you can accept a r.tensor, inspect the runtime d type of that r.tensor, convert it from bfloat16 into float16 in one branch, matchcast it as float16 in the other, and now continue all of your processing with a normalized input. And so this then becomes a powerful way to have a lot of data normalization, a lot of model inputs pre-processing that are expressed as sequential conversions, sequential applications of multiple different transformations that can all be simplified down at the compile time because now we have it all within one compile time structure. And so then the final one that is, just sort of something that came up alongside with this was, something that Stephen and I noticed in a TVM script related PR that there's, from a lot of the calling environments where most users are calling from Python, Python distinguishes between none and an empty tuple. Relax takes a lot of conventions from functional type languages where the empty tuple is instead used for, expressing a none or a nil type equivalent to Python's none, and so it is converted on input. But that also means that there's some ambiguity of what you received because the two concepts in Python are both being mapped to the same concept in Relax. And so that's sort of the intermediate solution that we found is, well, we can still have some amount of normalization applied in these cases, and this was specifically to then allow, cleaner TVM script printing, where if you have an assert statement, it would be cleanest to write it as just assert or r.print for a print statement. But because the Relax internal data structures express that as a variable binding, then it may need to be printed as a variable binding unless you have some way to know ahead of time that it isn't going to be used later on. I initially was thinking I could use the empty tuple as a way to identify things that are guaranteed to be unused because they are corresponding to a C-style void type, except that this isn't the case, and it is something that needs a little bit of extra help first in order to make sure that the unitary types don't have that or don't run into that issue. And so this is sort of different low-level functionality improvements that are all there to try to make Relax be easier to use, easier to read, and easier to debug overall, while still without restricting the functionality that's available.
Excellent. Thank you, Eric, for not only summarizing the PRs but also for raising them in the meeting. I think these are good changes. It's good to have an opportunity to discuss them live. I have a couple of questions, actually, ones that had not occurred to me in review. So thank
Hmm.
you for bringing it up for that reason as well.
Oh,
Um,
absolutely.
does anyone else have questions? I'll let others go first. All right, I'm not seeing any hands raised, so I'll ask my questions. Actually, since Eric, you raised on the uh, bool primitive PR.
Hmm.
Actually, you brought up since you brought up primitive values, you mentioned host side computations. This is actually, is it is it ever an issue that you could have a bool scalar on another device? I guess because they're scalars, right? They're always going to be on the host, or is that the
Uh,
case?
see, so depends. And see, the at the TIR level, the answer is, or actually at the relax level, the answer is scalar tensors could be on another device, but the scalar primitives are host side values. At the
That's what I
TIR
thought.
level, it could be on either, because you can have scalars in TIR, and those exist in whichever, say, device that section of TIR is being compiled for. And so, say, there's a uh, pass inside, say, the TIR lowering flow that is specifically to make sure that if you're calling a kernel that exists on a different device than the callee, that it then, say, is handled correctly and becomes a device kernel launch and recover the information afterwards. And so in TIR, the answer is it exists in whichever scope you are declaring it, on whichever device that scope exists, and any uh, data movements are inserted as needed.
Okay, well, my screen behind me is
Oops,
breaking
sorry
down,
about
but
that.
that's something I can address another time. Okay, so yeah, the reason I'm wondering is, yeah, do we? So first of all, because of the heterogeneous computation capabilities that Young added, we have a way to represent in relax, right? The constraint
Mm-hmm.
that things need to be on, host on CPU. Yeah, do we in this PR, do we need to insert any check like that? Yeah, because I guess yeah, my question is, can you have a scalar on another device that you then because at whatever stage that this manifests,
Mm.
presumably probably the relax VM, it will have to check a value that is not on the host, so it'll have to, either move it. So we
Mm-hmm.
have to, is do we handle this at all? I guess we
It
should at least
is.
detect this.
Oh yeah, it is handled as part of the TIR overall. Let's see, flow overall, where TIR say functions after lowering expose a packed func interface, and so if you pass something into that packed func interface, even if it is eventually destined for use on the uh, say GPU, it always must be received as a CPU value. And so if I compare it to a DL tensor, the DL tensor object always exists on the CPU. The data to which it points can exist on the GPU, uh, say, but the array of shape and strides, element offsets, and the data pointer to be used exist on the CPU. And so the way that it works is that they, let's see, everything that is initiated from the CPU accepts CPU arguments. And then any transfers that are required are either done through, see, let's see, data that is being pointed to is never implicitly transferred and is always explicitly transferred to the GPU. And so this is why in TIR, you need to provide a tvm.nd array that has its data located on the correct device. By comparison, scalars can be passed implicitly as part of the kernel invocation. And so if you generate a kernel that has scalar arguments, then you can launch that kernel using some value of the scalar argument and then have it available on the GPU. And so sort of the long way of saying it is handled, and but exactly which parts are checked depends on whether it's a scalar or a tensor, and exactly how it gets handled is backend specific. Oh, you're muted at the moment.
Okay, yeah, that was a hardware mute. Okay. Yeah, I'm just wondering, does for this for the context of these conditionals, is there anything we would have to do? Um, we
Mm-hmm.
could, I don't know, we could just make a test case and see what happens, of course.
And
Um,
that's effectively the route that I've gone here of making test cases for the behavior that I'd like to have work, and then seeing where it all falls apart.
yeah, yeah. Okay, so if we have a way to set up a test case, of exactly this, where, you have some scalar from a GPU value, we should at least make sure it's gonna, that if it
Hmm.
fails, it fails
Ah,
cleanly. We
so
should
in
figure
this
out.
case, this is something that the relax semantics help us with, because in the relax world, the primitive values are always on the host side. And so
Okay.
the way that this is implemented, because relax doesn't have a way to compute the prim values on its own, apart from VM specific handling of indices. And but what you can do is generate a host side primfunc whose sole purpose is compute one specific expression. This is not something that's exposed to the end user. It is solely for internal use, but you can then have that TIR function called from relax compute the prim value that you would like to have, and then return it back to you.
I see. Okay, well, yeah, my whole desk is falling apart.
Oh,
My microphone arm just fell off. I'll fix that later.
uh, sorry, I should add one last thing on that comment, that this host side function for computing the prim value is annotated with TIR is host func to say this should never go over to the GPU. And so we generate a prim func that matches the relaxed semantics that we are implementing. And
Okay,
so
I
because
see. So yeah, so this isn't behavior we've implemented though, right? Like we would have to generate these prim funcs.
this is behavior that is fully implemented in this PR.
Oh, okay, good. I need to look for that then.
Mm,
Wow, I
mhm.
I have missed that.
Ah,
Um,
yeah, sorry, I should have led with that, that this is full. And okay, yeah, this is showing way more files changed than it
oh, is that
should.
due to like a conflict or something, or a
Either
merge
conflict or
issue?
rebase, and so unfortunately I don't
Yeah.
have a good
Okay,
way to just show
great.
you the
Okay,
exact
I mean,
changes,
okay,
but
great. So, okay, if we have all of these facilities, that's awesome. There
mhm,
should be a test then for this
there
case.
there is a test
There
case
is?
for it. Mhm.
Great. Okay, you should have led with that. We
Ah,
have a
yeah,
test.
sorry, I should have let. Yeah, I started by writing the test case exactly as I would like to write it as an end user, and then went from there to where does this break, and what can I do to resolve those breakages?
Okay, well that's definitely the right approach. Good call on that. Test-driven development. I don't favor it for everything, but I think for this kind of thing, that's exactly
Oh
a
yeah,
good way to
especially
do
when
it.
there's such a potential gulf between how something is used and how something is implemented.
Exactly. Okay, cool. I will have a careful look at that. I apologize for missing it. That's really nice. Does anyone else have questions? I have some more open-ended ones. All right, that I want others to have an opportunity to ask if they have any. Okay, I'm not seeing raised hands. Um, so I did want to ask, yeah, I guess I wanted to put to the audience more broadly some of the design questions that come up here. There are kind of two that are apparent. So in general, for this use of prim values in if nodes and the assert op, I know we made the decision early on in development when prim values were first introduced. The reason I mentioned this is precisely because we did have a discussion on this many months ago. I could dig in the old notes to find when exactly. We wanted explicitly to make a distinction between scalar tensors and prim values. So it might be worth, I guess, revisiting what our principle on this is. Because clearly this PR works. Clearly, like it's not an implementation issue. I guess, is there any line we want to draw? When should something be a scalar tensor versus when should something be a prim value?
Yeah, I think normally it's happens in other languages as well, right? For example, in Python, you will have torch a NumPy scalar, right? Or a torch scalar, and then you will have Python native int. So I would view like the prime value as more like a Python native int and Python native float, which sometimes will be helpful, for example, especially when you want to pass in like shapes and other things from your environment, right? And then if you are just using it to do computations and then follow-up things, having them to be part of the scalar tensor or zero rank tensor is something that's usually more helpful. Yeah.
And I like
Okay.
that
Yeah, I
distinction
think
because
yeah. You
sorry, go
go
ahead.
ahead.
Oh, I like that distinction as well because it emphasizes here's the direction that automatic conversions can apply of say a prim value being promoted into a scalar tensor because say that direction of motion is an easier one to do as we can just add additional parameters to kernels or we can send a specific value over. But going in the opposite direction imposes a potential timing issues where if you want to launch multiple kernels all queued up at once, you might not have access to a value yet. And so I like the distinction of prim values are on the host, scalar tensors are on the GPU, because then that emphasizes if we only have implicit conversions from prim value to scalar tensor, it allows all of the operations we usually want to be able to do, scaling by a constant, for example, but doesn't do so in a way that would prevent later scheduling.
Okay. So is there any way we could, I guess, summarize the principle? Is the principle that scalar tensors are used for arithmetic and prim values are used for everything else? Or is that too simple?
Uh, I'm, I don't think I would say it that way because there can be, see, some arithmetic that is done as part
That's
of
true.
a prim value where, let's see, and see, I think I now have the
Yeah, you're right. Yeah, Eric, you're right. You don't even need to pull up an example. I think that's that's evident enough that yes, we have shape arithmetic that's done through prim values. That's true. So yeah, it's too simple to say simply arithmetic is for
Yeah, maybe I would
scalar
say
tensors.
tensors are for things that are expensive to move. Prim values are things that are cheap to move. And so if that's the distinction, then a tensor may not implicitly be migrated to a different GPU, because that's something we want to watch carefully for when it happens and schedule how that movement occurs. But passing a single prim value, well, that's cheap to send along through any function call invocation. And so those passing of data by prim value could be done automatically cross-device.
Okay. That seems reasonable. I guess yeah, I'm just trying to think, is this like, what is the design principle to advertise? You're adding a new op or something. When you're designing the interface for it, of like a scalar parameter, when does I mean, I don't know, maybe I'm just thinking too small. Maybe the conclusion is you shouldn't use scalar tensors. Like I don't know. I guess maybe that's the right question to ask. When is this
I think
good and necessary?
so. The way I think I would maybe say it is use scalar tensors whenever you are propagating a previous result. Use prim values whenever you're accepting something from the user. And the reason I would make that general rule of thumb is because a previous result that you receive might not have been generated yet. You can pass it as input to the next kernel to queue it up when it is supposed to be, as soon as it's available, but you have a handle to the future of the result, not the result itself, if you have a scalar tensor.
That's an interesting one. That's true.
And
Yeah,
so
it's true because a scalar tensors are mutable. So that is kind of curious. Um, I'm just not seeing like maybe this is the right conclusion. I'm just not seeing an obvious rule here. And I mean, and as Tianchi pointed out, this distinction exists also in NumPy, where maybe there's also no hard and fast rule. Also, some things operate on Python scalars, other things operate on zero dimension np.array.
Yeah, one thing I do want to notice that it also depends on front end. For example, extreme format like Onyx, they don't have this distinction between scalar values and zero-dimensional tensors, right? So as we import values from Onyx, you will find that there are, especially dynamic shape models, you'll find there are a lot of like shape manipulation operations as part of the computation. And actually, there can be optimizations in those cases where your pattern match zero-dimensional tensor computations, where they supposedly they should be, symbolic shape computations. Like, so that's like one case where, maybe that will be benefit. If people write code in zero-dimensional tensor, but the real intention is that they could be lifted into those scalar computations. You might be able to rewrite it so that you kind of, it's like a pushing the scalar conversion earlier, right? So yeah.
Yeah, I don't know. I mean, it's such a, I
Yeah.
don't know, it feels like a very subtle issue to me,
Yeah,
but it's
maybe
important.
this would sort of be if it's which things can be pushed earlier, if it's use prim value when something can be pre-computed, use a scalar tensor if it's cannot. And so effectively, like, so as some of the motivation for these as well, see, I have on the back burner a check for special case, relax IR module transform. The idea being you tell it this set of dynamic shapes is a special case that will occur frequently. And so whether that's the special case being is divisible by 16, whether the special case is this shape is exactly known to be this static shape. And so then you can delegate out into one of two different paths. And you can say, same user-facing interface, we'd really like to call the static shape optimized kernel every time that we can. But if we can't, we don't want to just throw an error because, well, the thing we had at the start of an optimization pipeline accepted any arbitrary user inputs, so we don't want to lose that flexibility. And so if we have something that is deciding which GPU kernels to launch, that almost by definition needs to be on the host side in order to make that decision. It needs to be something that's pre-computed and lifted out into a host side computation. And so I think all of these definitions start playing together because Tianqi's, is this something that can be lifted out from the GPU? See, my thinking on, is this a cheap computation to perform to check, hey, is this divisible by 16 before doing 10 million floating point operations? And is this a host side? And so we sort of have a list of properties that are things that would be useful to have it be as a prim value. If it is cheap, if it is host side, if it is something that can be performed quickly on the CPU, if it's something that can be lifted out and treated as an immutable scalar, then these are all, none of them are definitively, then you must have a prim value, but all of them are, but then you probably should have a prim value.
Okay, I like this way of putting it. I guess, yeah, these are more than design principles where you should consider doing it, but you don't have to. Yeah. So, okay, this is starting to sound, I mean, okay, this makes sense. We're getting into low-level territory. And when you're in low-level territory, there are multiple ways to accomplish the same thing, some of which are better than others. I've been reading a lot about, like classic C programming, and C is full of this stuff. I mean, where, yeah, you can accomplish many things you accomplish the same thing different ways, but it's not going to play out the same way. So, okay, this is fair. So maybe, yeah, when you're dealing with prim values, there's kind of the disclaimer, you are now doing low-level stuff. This may work, but it might not be the best for you. Here are situations where you should consider doing it. I'm fine telling users that. And then I guess when we're dealing with tensors, that's where you're leaving things up to the compiler to do more things for you, potentially. So, okay.
Yeah, and so
I think that's fine.
I'd almost go, the prim values are the deliberately restricted usage that can then be optimized more effectively. The scalar tensors are the more flexible thing to have that you can do more operations with. And so then you could always have a prim value to scalar tensor conversion, because that's just loosening the restrictions and letting it be used in a more flexible manner. You can't go the other way around and say, I am going to tell the user this is definitely something that they should have used a prim value from the start, because then we're putting assertions in the user's mouth of this does follow all of those properties. And so sort of one of the things is where we'd like to do a lot of the computations if they're cheap, but we can always go in the other direct. It's a one-way street for the compiler. The user has the options.
Okay. Oh yeah, I'm fine with taking that as the line. Okay, so yeah, so yeah, we can say using a prim value, that's always a choice available to you. Consider it carefully. I'm gonna have to revise the spec to account for this once this is merged. So that is the line I will put in the spec. So okay, I'm just thinking, are there? This is like a separate question. Are there other corners of the language then where we might want to handle prim values where we're not currently permitting prim values? Is there anything that jumps out at us as, something to put on the list?
So I think the big one is arithmetic operations. You cannot accept a prim. There isn't a good way that I have found to say divide by the size of an array. And so if it's something like, I would like to normalize everything so that it sums to 1. Let's see, I can make a scalar tensor that has the sum of an array of 1s, but that seems like kind of overkill, because what I'd really like to do is say, hey, this prim value is n, and I would like to do relax op divide tensor by n. I cannot make this as a r.const because that must be a compile time constant. And this prim value could be made into a runtime constant, but that's not an r.const. There is a relax.full, which could let me make a 0-dimensional tensor with some specified, fill value, but that fill value must be specified as an r.const, as a scalar tensor. And so I think the big thing is, I think it should always be legal to promote from a prim value to a scalar tensor of the same d-type in all circumstances. And I'm sort of saying that as a very universal statement, as a way to try to invite as many edge cases as possible of when we wouldn't want to do that. But if I start with, that would be a good goal of always be able to automatically and implicitly convert a prim value to a scalar tensor. I can't think of cases where we wouldn't want that functionality.
Yeah, I can think. I would think maybe the only time where this could be problematic is prim funcs, actually, because prim funcs care about the representation, right? Because what we're saying at the higher level, in the relaxed level, prim value and a scalar tensor, they are different ways of representing what is the same thing, that thing being a scalar value. And so relax abstracts over that. TIR doesn't, so that's the only time where you need to think about how it's represented rather than what it conceptually is. Let's see. I'm just thinking. So okay, like when would this manifest? Call TIR, direct calls to prim funcs, packed func calls potentially. So I guess that's the other thing. Packed funcs also care about the representation because they're also, they can do anything. So you need to know the representation.
So would it be valid in those cases to say we can promote it to a scalar tensor when required? It's not that it is automatically always normalized to a scalar tensor. It's that for a given packed func, we have a func struct info. We know what argument it would like. And so saying we could say this is a step of normalization. If you have a call that is providing a prim value, but the func struct info expects a scalar tensor, this is not an error. This is a normalization step that occurs at that point of wrap the prim value into a scalar tensor.
Okay, yes. So for prim funcs, we could do that automatically, which is nice
Mhm.
because we can look at the definition. For a packed func, we can't. So there needs to be a manual override for packed funcs. That's which is kind of just the consequence of dealing with packed funcs.
Mhm. And so I think that
Yes.
sort of becomes.
Tianchi has to go. Thank you,
Sorry.
Tianchi.
Thank
Sorry to
you.
interrupt.
Yeah, so maybe that becomes this conversion must be explicitly representable in relax. It's a normalization step that occurs, but it is not something that is silently normalized. It is something that produces a normalized version. You, as the user, if you are calling a packed func, can then specify exactly what the parameter take that you are passing it is. And so, in cases where there is not enough information to normalize, then we don't know if it should be promoted or not. So, you have the flexibility to express it.
I see. Okay. So phrasing this as a promotion. Okay, that's I think that's more manageable. Okay, good.
Mm-hmm,
Okay, so that means yes, the type system can tell you what it is,
mm-hmm,
and then yeah, if it needs to be promoted, it can be. You always can do it manually. I like this. This is how systems programming languages these days tend to do
mm-hmm.
things. C++ is wonderful and horrible for doing this sometimes. Implicit conversions, promotions, things like that.
You mean
But
you
that's
don't
fine
want your
as long
integer
as
to
the
become a
rule
string?
not yeah, I don't think there are limits to how
Sorry,
far
C++
you can.
joke.
Yeah, there are limits to what you can do, of course.
Mm-hmm,
Yeah, as long as the rule is easy and predictable, I'm fine with
mm-hmm.
it. I think yeah, promotion rule very very doable. That should not be crazy. That's not hard to reason about. So okay, I like it. I think let's digest this one for like a few days and see what makes sense to write in the spec then. I like
Yeah.
this idea very much. Yeah, I just need to I need to stew on this one. Okay, cool. I have one last topic I wanted to
Mm-hmm.
raise, also related to these PRs.
And if we have time,
Oh,
I have one last thing that we can discuss, but I've also monopolized a lot of the time today, and so you should go
hey, this
first, I
is
think.
it's good discussion. No, it's good discussion. No, I
Mhm.
just it was a question related to one of the PRs. So actually, so Tenchi left. That's unfortunate. I wanted his opinion on this. I guess it's more comment than question for the units. The question of the unit tuple. I mean, when we compile it, the whole deal with the unit tuple, the unit value, is that there's nothing you can do with it. It is right. Empty tuple is a type with exactly one value that inhabits that type, and there is also absolutely no information that the type contains. So I'm just pointing out, the reason it's safe to inline this is because there's nothing you could possibly do with this value, and in fact, in compilation, we can just strip all unit tuples wherever they're used. Because they never do anything. You can
They can be placeholders.
Yes. So yeah, you need them for signatures to work. So yeah, for a packed func, you can't get rid of it because the argument needs to be there.
Mhm.
Um, but what we can do, for those cases, we could just intern a single value of that type and use the interned value everywhere. I'm just pointing out, yeah, this should not be like unit tuple is the last thing we ever need to worry about because it is deliberately the simplest possible type you can have. Um, so yes, that's the only thing I want to say. Don't sweat the small stuff, and this is definitely small stuff.
Mhm.
Okay, Eric. So I guess the floor is open. What the topic you wanted to raise? Go ahead.
Yeah. So this is more something that I've been noodling around with and seeing, can I make a good interface for pattern replacement that can be applied either to slim or to relax? Same pattern definition, applicable in either case. And the reason for this is uh, the slim model definitions are a lot easier to write. They're a lot more familiar for users who are coming from a PyTorch world. And They are easier to inspect at a high level and give names to what the different components are. If you have a 10,000 line list of relax operations, it's hard to say what any one of those is doing. If you say this is the attention layer, then that's a lot easier to work with at a human level. And so the goal here, and this is something where it's as a draft in large part because I want to have a conversation on it, because I want this to be a useful functionality. All of those things that are true about Slim for being easier at the user side make it harder to work with at the compiler side. That the existing compiler level optimizations don't apply to Slim because it's a different representation. All of the different optimized kernels that could be written in Slim, well, those only work if you have the existing nn.module implementation that you've written that for. And so there's a bit of a mismatch between what is easiest for an end user to describe and what is most flexible to use as part of a mix and match, apply all of the optimizations that are useful and profile to see what you want to do, compiler flow. And so this is my attempt to say, or to ask, can we have both? And so, let's see, I'm going to sort of jump to the usage because I think the usage is key, more so than any of the implementation details. And if I go to the test, the idea would be, suppose the user has something that they have written, and now you can write an optimized version of that. You are subclassing the implementation. This was a feed forward. Now you have an optimized feed forward. You are providing, let's see, and that sort of defines what you are replacing at the Slim level. Any instance of the feed forward class can be replaced with the optimized feed forward class. And then this is just use it in some nested structure so that way you can display it. But then it's okay, yeah, if you have this subclass of an optimized network, then nn.replace implementation. This is now a Slim mutator that can inject that anywhere you'd like. And so no need to rewrite your entire, end-to-end model definition, Hugging Face style. You can say, here's my optimized version. I'd like to inject this. And now we get to the really cool thing. Mutator.asRelaxTransform. Given a Slim mutator that is written in this style, turning it into a set of relax pattern matching rules that can be applied as a relax to relax transform. Because all of a sudden, those limitations about Slim go away. See, oh, you had to have exactly this feed forward class to apply it in Slim? Well, if you do it as a relax transform, so long as you have whatever forward inference function that class provided, you can apply the optimization anywhere. And oh, you had something that was, split where this pattern didn't occur neatly along a nn.module boundary and didn't have a name. That's okay. We can still extract out the matching portions. And so the idea would be to make it as easy as possible to write the slim mutator, but as constrained or just constrained enough that we could write it as a relax mutator at the same time.
This is very interesting. So is the intent for this to be kind of coarse grained then? Because I imagine Slim is an even higher level interface on top of the high level interface. So I imagine just simple substitution. That's the kind of optimization you're going for at this level.
Precisely.
So yeah, we don't need granularity like, replace conditionally, for example. So yeah, so this is just subgraph matching. Is that
This is
how
purely subgraph matching.
Okay. I mean,
so
it's lovely.
Thank you. Yeah, and that's
no, especially lowering into relaxed to relaxed pattern matching. That's a great feature to have. So I didn't quite understand your last comment. So you're saying by lowering to relax that so does anything change in the lowering? I guess what I'm trying to understand, you made a mention of and this is because also I have not looked too much at Slim. So you said there would be an issue with nn.module boundaries, so there would be limits to the pattern matching, and
yes,
those limits wouldn't apply in Relax though, because Relax doesn't do that.
Precisely. Yep. They would not apply in Relax.
Okay, that seems a little bit actually though. That seems like a little bit tricky for users though. Like a user would not expect things to change because you lowered it.
Correct. And this is sort of where that's the ambiguity that I think is where a lot of the usefulness comes in. That if we say here's a list of different transformations and these are valid transformations to perform, that doesn't necessarily mean that at the Slim level they are going to be applied wherever they are possible and valid. At the Relax level, they are to be applied wherever they are possible and valid. And sort of, we can impose the same restrictions on, say, the Relax modules that we generate. About half a year ago, I implemented a defined subroutine option for, see, the Slim to Relax conversion, where by default, everything is output into one giant function that has the entire end-to-end module. You can also specify and say, I would like each Slim nn.module to be its own function inside the resulting Relax graph. And so this would be a way to impose the exact same boundaries within Relax for the pattern matching as exists within Slim for the pattern matching.
Yeah, I see. I'm just not sure what to make of this from like the design point of view, because like I said, when you lower things, you expect things to be kept the same. If this is like an ambiguity that just inherently exists in Slim, like I guess anyone who uses it would already know that this is something they have to think about. I don't have an answer because Slim again. It's
and this is
not really my portfolio, but I mean, I don't know. I mean, certainly defining like simple substitutions, that's, a capability I think people would expect to have. So I'm for that. The implications I think are kind of interesting to digest. I think we should definitely have wider discussion on it.
Oh yeah, and that's where the implementation of this is, I think, less important than is this something that people would find useful? Because for me,
hard for me to say, because like I can't really comment on it because for example, I'm not in the population of machine learning researchers who write models in PyTorch and expect things to happen at the model definition level.
True.
So yeah, I'm not the audience for it, unfortunately.
Mm-hmm. Yeah, and so this is effective, and I'm not to some degree either. And so it's sort of, yeah, I want to get this in front of the people who would be writing a PyTorch model that has a lot of optimizations baked in already at the model definition, and say, is this something that you'd like this functionality for? Because that's, I think, a really strong way to go of if we can provide the same functionality, but in something that is easier to integrate into an optimization pipeline, then we get a lot of benefits for it.
All right, I think that's a good note to end on. We are at time. So yeah, I look forward to hearing more about slim pattern matching. Like I said, unfortunately, I'm not the best person to ask because I don't really know. The preferences of people who are writing models at the top level. But definitely a discussion worth having. If you know people in the TVM community who would be the best to ask, we could try to invite them to one of these meetings and have a discussion precisely on that topic. Well, let me know your thoughts. I think this is a good spot to wrap up.
Agreed. Yeah, I think I may try to make a discuss post about it. Let's see, as that's probably the spot that would get the most attention from new users, who is exactly that who I want to aim this feature towards.
Very, very good. All right then. Well, thank you, Eric. This was a very productive discussion. We touched on a lot of topics. Look forward to seeing everyone in future meetings. Oh, I guess I should have this while we're recording. Before we recorded, we had a discussion on meeting times. It is daylight savings time in the U.S. However, many attendees do not live in the U.S. So we will be moving the meetings back 1 hour so that the meeting time will stay the same for places that don't have daylight savings, which is most of the world. So there will be this meeting took place at an unusual time relative to everyone else. Future meetings will not. Thank you. Thank you very much. Just want to put that on the record. And see everybody in future meetings. Goodbye.
See you later.